Important for you to write down because this is times. If you didn't have these times, how would you be able to figure out how to separate all this data? Okay, this is all the tracks. You know, we have 8 groups of data. How would you figure out, if all you had was the GPS, how to, when they started and when they stopped?
You got the UTC time on the GPS data.
You have the UTC time on the GPS data. But without knowing, and that's what we're going to use, and let's get to that. So we have the local time, and we have to compare that to the UTC time. So that should be relatively easy, right? UTC time should be, and if I looked at, do I have it in here? Yeah, here's some UTC time. This is kind of when we started, 1603. Well, that should correspond somewhat to this. This would have been 16. We can see that well, you can't actually see that we're not moving, but we really started moving at 22. Here we're just sitting there collecting data. So the concept was, if I just had the GPS data and not this, how would I know when the group started and when they finished? All I have is the GPS data.
Velocity.
Velocity. Now that's a because velocity. Okay, we're out there. We start, and we're out there spraying, and we slow down, and we start, and then we come back, and then we sit there for a while, collecting data. But we're not going anywhere. So if I went ahead and plotted velocity, and I think I did that. Well, I didn't say I did that. And because I was trying to figure, well, what if Jessica lost all the time? What are we going to do here? And so I plotted. Let's see if this can be it. Let me think about it. This could be it. Did you actually see anything there? Yeah. And if I plotted the velocity, here's our 4 groups. This is the first. This is velocity, just SOG, speed over ground, off the RMC string. The units are in knots. It really doesn't matter to us. We're just looking at velocity. Here's where I'm just sitting there, 18, right? Sitting there blabbing, yeah, turning on, talking. And then at 1822, that's 1820, that's 1825. At 1822 is when I start. Oh, that corresponds to that. And here's the first set of data. And then we sit for a while. And this is maybe where we changed operators. And then we sit for a while. And then here's the second group of data. They may have stopped in the middle of that. And then we sit for a while. And here's the third group of data. Here's where they stop to change. And then here's where they sit for a while. And here's the fourth group of data. Here's where they change. And then here's where they stop. So by looking at, I guess the point thought is you can get a lot of information out of GPS by just having that data stored.
Why did it make this map or this Excel graph like this instead? Because everybody basically started on the first swap is the same. Does that make any sense? So even though this is showing, I understand what you're saying about how the tractor's sitting, so obviously there's switching going on because it wasn't moving. But why is it plotting it like different?
Time.
So it is plotting time.
This is time down here. I plotted velocity versus UTC time. This is not position. Yeah. Sorry, I should have made that clear. Velocity versus time. What's happening out there? And a lot of times that's can be very valuable to if you want to try. Sometimes if you're trying to synchronize some things and it's hard to. And you didn't really synchronize it well, you can kind of look at some velocity data and say, okay, when was I sitting somewhere? And where's the other data set in which I'm sitting? And then you can kind of almost synchronize it that way. But the value is that if we didn't even have this, we could have separated out those data sets. Okay, but we do have this, and we hope it matches up, right? We hope this 22 to 27 goes from 22 to 27. Okay, that's pretty good. And the next one goes from something a little bit over 30. Yep, a little bit over 30. And let's see, here's where they start, and here's the middle, and then it stopped at something less than 40. I'm looking at here, like a 37 or 38. That's 38 right there. So you can basically don't even need those. You can figure out, separate your data sets just based on velocities. Now you could also have figured out, okay, when did they actually go back to a certain location? And here they're plotting. And in one of the ArcGIS, and I don't even know if I'm going to demo this, but one of the ArcGIS extensions is called Tracking Analyst. And you can actually pull in, not really raw data, you have to convert it to decimal degrees, but then you can actually see this thing moving in the field, which is kind of clever. And then it comes back to this point, and then it's back there. And so you can see animation of GPS, and we actually have that in several of our studies. Okay, so this is the start and stop time. Now, what do you expect it to do? Well, we've already talked a little bit about this is the data, and I'm going to show you what the data kind of information that's coming out of the data. Is the data any good? Well, I went ahead and did a little bit of analysis. Oh, no, okay, of the data. And where this is the UTC time, this is decimal degrees. Now, obviously, I had to go in and do the old, okay, let's take your degrees in minutes and separate that out to get decimal degrees. Let's make it negative. And I always forget to do this. Let's put the longitude first and then the latitude, so when you do the XY plot, it makes sense. So that's our decimal degrees, longitude, latitude. Here's our fix, which is 2's. All were differentially corrected. Here's our 100. That's our base station. So it was using OmniStar. If it was 122, it would be WAS. This is our age of the differential correction. You can see that, about I get the signal comes in around 2.8 seconds. I use it for about 7 or 8 seconds, and then I get a new differential correction information coming in from the OmniStar satellite. And you can see that the oldest signal I have is, somewhere around, it's around 2, and there it goes up to 9. So the update rates are pretty good on my differential correction. My H-stops, pretty reasonable. And you can go through and average all your H-stops. I'm not asking you to do that for this lab. But you can, this is my H-stops, 0.9, 1.2 is good. Number of satellites look good. And you can almost see that it corresponds. The more satellites I have, the lower my H-stop. As my satellite numbers go up, my H-stop, as my satellite number goes down, my H-stop goes up. So this is all quality control checks, just to make sure the data looks good. And then you go in and then you plot it. And fortunately, it's all on the same page, which is good. So it's all on the same page, and these are all the tracks laid up. Now I'm going to ask you to say to separate these out. Compare the parallel swaths obtained without guidance to the ones that you're doing. So we're going to have 4 parallel swathing operations that went on. 1, 2, 3, 4. So I want you to compare each of those, 1, 2, 3, and 4. What do I mean by compare? We'll talk about that. To what was done by George, which actually doesn't look too bad now compared to what we did, right? Because he's just driving straight. Yeah, he might be off at an angle somewhere, but he's not going woohoo like that, like we were doing, right? Okay, so there's a little bit of operator adjustment